Hello friends. This video is brought to you by mywayteaching.com.
Let us learn another method of proving congruency of triangle by use of appropriate measures. Say we have a triangle and we have to make a triangle which is congruent to this one. So we have already found that giving the length of one side is useless and more information is required to draw a congruent triangle to this one. So if I give you one of the angles on this line, still it won't be possible for you to draw a unique triangle or the triangle that is congruent to the given triangle. But if I give you the measure of another angle on the same base, then of course you can draw a triangle which is congruent to this triangle. You can draw a line segment AB 4 cm in length with A as center, and using a D we can construct a 45-degree angle. Similarly, with B as center we can draw a 30-degree angle, and these two angles will intersect at some point C so as to give a triangle ABC which will be congruent to the given triangle. Hence we now state ASA property: if under a correspondence two angles and included side of a triangle are equal to corresponding angles and the included side of another triangle, then the triangles are congruent by ASA property. Let us now consider ASA congruency rule as a theorem and prove the result that two triangles are congruent if two angles and included side of one triangle are equal to two angles and the included side of another triangle. This result is considered as a theorem as it can be proved using SAS property. We are given two triangles ABC and DEF. It is also given that the two corresponding angles, say B is equal to E and angle C is equal to F, and the included sides are equal. And we have to prove that triangle ABC is congruent to triangle DEF. Let us start with the proof. Keep in mind that SAS property is an axiom and we shall use SAS property for the proof. Now, since already one side and angle of ABC triangle is equal to one side and angle of DEF triangle, so if we can prove that AB is equal to DE, then the triangles will be congruent by SAS property. But it is not given, so the three cases arise, that is, either AB will be equal to DE or AB will be greater than DE or AB will be less than DE. Let us take each case one by one. If AB is equal to DE, then we already know that in triangle ABC and DEF, angle B is equal to angle E and BC is equal to EF. So, we have angle B equal to angle E and BC equal to EF. So, triangle ABC will be congruent to triangle DEF by SAS property. Let us move to case 2. If AB is greater than DE, then we can mark a point P such that PB equal to DE. Also, it is given that angle B is equal to angle E and BC equal to EF. So that means triangle PBC is congruent to triangle DEF by SAS axiom. Now, since the triangles are congruent, all the corresponding parts will be equal. So that would mean that angle PCB should be equal to angle DFE. So we can write that angle PCB should be equal to angle DFE by CPCT. But it was given that angle ACB is equal to angle DFE. This is given to us. So from the two equations, we can say that angle PCB and angle ACB should be equal. So this implies that angle PCB should be equal to angle ACB. But this statement is not possible geometrically. Let us look at PCB is this angle, while ACB is the complete angle. So this condition can arise only if P coincides with A. So that means P should coincide with A, and hence the congruency becomes triangle ABC is congruent to triangle DEF by SAS axiom. Let us now consider a third case when AB is less than DE. Since AB is less than DE, we can choose a point M on DE such that ME equal to AB. So, and now we can prove triangle ABC and MEF congruent, and proceed in the same manner as in case 2 and prove that M should coincide with D since angle F and angle C are given to be equal. And so, if M will coincide with D, then we will have triangle ABC will be congruent to triangle DEF by SAS property of congruency. Hence, we have proved the theorem that two triangles are congruent if two angles and included side of one triangle are equal to the two angles and the included side of another triangle.